works up to this point, but then what takes over at that point? The line. So if I were to turn these limits around, instead of going, letting y go from this to this, and that's fine, that has no weird points in the middle. It always goes from this to that, this to that, this to that, all the way through, right? If I turn it around, what's x doing here to here? It's going from 0 to square root of 1 minus y squared, right? Turning this guy around, is that cool?
Okay.
All right, so far so good. And then at this point, I can do the integral of this from root 3 over 2 to 1. From 1 to 1/2 for x. And what's going to happen here?
Switches. But wouldn't that be a triple integral?
No, it won't be triple. It will just be two double integrals. There will just be two double integrals because you have to have one integral from here to here and then another one from here to here.
Okay,
right?
So that's why I was confused because you said two integrals and I was like, but we.
Now that I've said that, I want you to realize that's not what this problem asks you to do. I just want to say it. Since we were talking about doing that earlier, about switching limits, what this problem really asks us to do is to convert this to polar. Now don't take these stupid things and try to plug stuff into them. Look at the region. What defines this region? What does R go from to? What's the radius go from to? 1. It goes from 0 to 1. And what's theta do?
Pi over 3 to pi over 2.
Good. Why is that pi over 3?
I don't know.
A square root.
It was just subconscious.
Unstoppably honest. I love it.
Sine of theta is equal to square root of 3 over 2, so that would be.
Yeah, now think about it. Look at this. This is the unit circle here, isn't it? And the y piece is root 3 over 2. And that would mean that sine, it's got to be a bigger angle. The sine is bigger. So it's got to be 60 degrees, pi over 3. So it goes from pi over 3 to pi over 2. Holy shit.
Don't you just love this?
Wow. So what would this integral look like now? What function now is when you worry about what function you're integrating. Because it used to be in Cartesian, now I need it in polar. So what function was I integrating? X. So I know on the inside I'm going to have r cosine theta. And what's going to be back here? r d theta. I like it. And what do we say r is doing? Now it's the easy part. R is going from 0 to 1. Theta is going from pi over 3 to pi over 2. And that should go pretty easy.
You should have showed us this before you gave us the answers. Just saying.
You gotta have willpower. Don't look at that answer key. Don't have willpower, and it's not part of what I teach. I'm sorry. Oh, can't do that. How are we doing with that? Is that
Bueno.
okay? Where do you guys want to go from there? Did you have a... Today's review day. You can break whenever you want to.
26, 12, 8.
I'm not sure if 12, 8, 26, that's the one that I'm talking about. I was going to ask you. I have some magic pens.
I like it because
I'm kind of surprised we haven't had any questions from 12-9.
Haven't done it yet. It's coming.
So this is 12-8.
I'm just like so used to doing it. I feel like.
No, one of my teachers from actually, what is it? Geometry teacher. She dated a blood dude, so she taught that whole crap.
She dated a blood dude, is that what you said?
Yeah, you know, like the bloods and the grits.
Oh, I was wondering if you meant like a hematologist or
Well, she's talking like actual blood.
blood dude.
Yeah.
Yeah, data textures. You know. So this one says to find the was it absolute?
Critical point to the next
Yeah, critical. And then use the second derivative test. And just remind you guys, I said I would have the layout for the big D dude up on the test itself, so you don't have to try to memorize.
All the discriminant?
Yes.
Wait, what do you use?
So I'll give you those.
Right.
I'll give you page 855, the second derivative test. Those four.
855.
I know. For me, that's extremely nice. So guys, what's the first step here to find critical points?
FX and FY.
Guys, so you can take a break anytime you want to. Sweet, so you find fx.
And FY and 7 equals 0.
I like it.
Do the question rule.
What's that?
She says she doesn't like it. Give me do the quotient rule, man.
Aww.
Bunch of stuff.
Make me cry. That was so sympathetic.
Yeah. Wow. Wait a second.
Oh, too bad.
How do you find out 0, 0?
Quotient rule in terms of x.
Alright.
So you get it.
So quotient rule, it still applies because fx is treating y like a constant, so it's the same as always. So I always just remember top first whenever you do quotient rule, and that got me going. So do the top derivative first with respect to x.
So it's x squared.
With respect to x, 2xy.
Minus y squared.
50 minus 2x minus 2y.
Now the bottom. Let me just put this down here.
And then you multiply by the bottom.
What's the derivative of the bottom with respect to x? 2x. How's that so far?
Isn't it like derivative of the first times the bottom minus?
Oh yeah, yeah.
Okay.
Wait a minute. My wife's doing that.
Teach is learning from the student.
This happens all the time.
Mine.
So then here's the derivative of the bottom times, and it's minus the top. I'll tell you this. I don't know how many of you guys do this, but I really never did quotient. I hated quotient. So
Oh, yeah.
It's easier because you're setting it equal to 0, so the bottom will cancel out.
You always say
Yeah, but now when you set it equal to 0, the bottom
So
just
easy.
cancels out.
Well, you almost always set it to 0 next anyway. So either you.
Well, if you have a product rule, you just, no.
Anyway. So now I see what I can cancel out here, right? Let's see what happens. This is crap. All right. Plus 2xy cubed minus y squared x squared minus y4 minus 2x cubed y plus 2x squared y squared. All over this. So does anything?
You can pull out Y's.
It's just too much of a pain in the ass.
Let's see. Let's go ahead and kill the bottom anyway, since we're going to set it to 0, right? 2x cubed y minus 2x cubed y, that's nice.
Yeah, so
That's it, right? Oh wait, negative y squared x squared, so I get 2xy cubed plus x squared y squared minus y4, right?
yeah,
Over that crap, and it's equal to 0 anyway.
go from there.
Pull on y squared.
Pull on one
Yeah, divide, so y equals 0 is one thing, isn't it?
Yeah.
So y equals 0, and then I can divide by y squared, and get 2xy plus x squared minus y squared.
Wait, why?
What do you do with
0?
that? Doesn't factor.
What's up?
Wait, why'd you
What did
put
I
y-
do from here to here?
Why'd you put a y equals 0?
Because what's one answer to this?
Oh, okay.
The trivial answer is if there's a variable and everything,
I
it's
thought
set
you were
equal to
plugging
0.
in 0 for y.
So I have to say y equals 0, and then I'm allowed to divide by y, because I'm saying, okay, for every other y, I'm allowed to kill it.
Okay.
Right? So I pull out the answer, then I divide it away. Don't worry about him. Let him sit there and stew in his own juices. So now come over here and do fy.
The answer will be the same, just you're gonna get x to the fourth minus 2xy minus y squared.
Oh,
Sorry, you have x cubed, 2x cubed, I factored out, yeah, and yx squared, x squared.
like that?
Yeah.
All right, I'll take your word for it.
She's lying.
to get to the chase here. So now you can do the same thing. So x equals 0 is one possibility, right? So then you divide by your x squared.
Yeah.
And this is x squared plus 2xy minus y squared. If you just want to make it look a little more symmetric. You can't factor either one of those, right? And it looks like they do have answers. So
Now
not
you
pretty
can-
answers.
Now you plug in zeros.
Hmm?
So you plug in y equals 0 for that one.
Yeah, so they have to make both things 0, right? They have to work in both. So one thing you can do right now is, let's see if this is anywhere. If you set them equal to each other, what's it going to show you?
That 2 doesn't equal -2.
Oops, there we go. Yeah. You good with that? They have to both be 0, so they have to equal each other. And then this goes away, and then negative 2xy equals 2xy. Which basically says
I don't work.
Zeros, it doesn't.
x equals y equals 0, right?
Yeah, which is, it's undefined at that point, right?
So either x equals 0 or y equals 0, which means the other one can be anything it wants to be. What did we figure out from over here?
But they both have to be 0.
Y equals 0. So it looks like it only has one critical point, 0, 0.
It doesn't have
But it's not a max or a min.
No, because
it's a
0, 0
critical
can't be
point.
on the bottom, so it has no
Yeah,
critical
it's
points.
only critical point.
Beautiful, I love it. So the only possible critical point is not in the domain of the function,
Yeah.
which means what?
No critical.
No critical points. I mean, if that's the way it is, it's the way it is.
It took me that long to realize that.
No, I like.
The solutions manual before.
I know,
Are you guys? So don't think that everything has to have a critical point. We've seen a lot of functions in Calculus 1 that didn't have any critical points. Not a ton of them, but enough.
It's not fair they make you do all this work.
No idea. No
Okay.
idea.
I'm sorry. I can't be simple.
Ooh, it can play this.
You guys want to do some Lagrange stuff, and then maybe that'll be almost it.
Just a question
Yeah.
about this one, but also the critical points is the point that make the function undefined, right?
Yeah, yeah. So you already knew from the beginning that x and y being 0 made this derivative undefined.
So there is a critical point.
But it's not the domain of the function. So there isn't. It's undefined at that point, so no critical point.
Oh, it's no sugar, right?
Because the only possible critical point is not in the domain of the function. Get him out.
You leaving?
So any specific questions from 12.9?
Well, you started to do 12, or 28, and you just like stopped. I didn't know where to go with it.
Sorry.
What section are these?
Oh yeah. All right.
Here's the difference.
I used to be.
My bad.
Oh, cool. You guys restarted.
I haven't seen you.
So, I injured Stu, it sounds like, by not finishing number 28. So can you help me?
Okay,
So it
so-
started off like this. Let me put it down here for myself real
What
quick.
section
Yeah.
was it?
This is 28.
Page
Your
87.
constraint was 4L plus 2G equals 12.
What do they call it? They call it
G, or I don't even know what they called it.
Oh yeah,
G.
4L plus 2G
M of LG.
Yeah, that was LG.
equals 12. So guys, I'm gonna put down, we do this, UL equals lambda, G, lambda, whatever the hell, yeah, we called it M, right?
Yeah.
M,
and U G equals lambda mg, blah blah blah, and that got us to what?
It was 64 thirds L to the negative 1/3.
64 what?
Thirds.
Thirds?
Yeah. L to the negative 1/3 times G to the 1/3 equals 4 lambda. And then that was our first equation. And our second one was 32 thirds L to the 2/3 G to the 2/3.
G to the negative 1/3.
Negative 2/3. That's probably right. And then it equaled 2 lambda. And then our third equation was G equals 6 minus 2L. Yeah.
Okay, I like it. That's just taking this guy, right?
Yeah, and then you kind of just.
The last one of your system equations is always the given constraint function.
Yeah.
Okay, so when in doubt, what do you do? Solve for lambda and then set them equal to each other, right? So you divide this by 4, right?
Yeah.
Divide by 4, you get 16 thirds LG, and then divide this by 2, you'll get 16 thirds LG. How are we doing?
Right, but-
So I took this one divided by 4 to get lambda by itself.
Okay.
This one divided by 2 to get lambda by itself, and then set each of those equal to each other because they're both equal to lambda.
And then you took the third equation and that's where you stopped.
So now what can I do with this? Those go away.
Yeah.
So I get, these kind of complete each other, don't they?
Yeah.
If I multiply up by this, I get a whole G, and if I multiply this, I get a whole L.
Mhm.
Okay, see that?
Oh.
And I get a 1/3 and the 2/3 complete each other and the other way around. And then if you plug that into here, you can solve for one of the variables, right?
Yeah, so that equals L.
So G equals 6 minus 2G. 3G equals 6, so G equals 2.
Okay.
Which means L equals
L equals 2.
2. Now that's what I get from setting these two equal to each other and then plugging it in there,
Mhm.
right? Are there any other possibilities?
Well, the first time you did it, you plugged the equation G equals 6 minus 2L, and you put it into that equation up at the top right. Or
Did I? My God.
Yeah.
Why did I do that? I was
That's what I was left with when I was like.
I'm sorry. I didn't mean to do that to you.
Okay.
did I really? God. So there, we got a critical point right there, right?
And just plug it in, right?
And then just plug it in, yeah.
When like on some problem like the practice test, you get like multiple answers, like negative, plus or minus. Hold on, let me look at the question. It's number 4. Yeah, number 5. I'm not talking about that. Number 5 on the practice test.
Yeah.
You got z equals plus or minus 5 over square root of 2, and that means y is equal to that and x equal to that. How can we, like, know what's the possible combination of the point, you know what I mean? Like, if you turn the page, you only have 4 points there, or pretty much 8.
No, yeah.
My question is, how do you know the combination of that? Do you have to, like, try each one of them?
Oh, the reason, are you having trouble with why I grouped them the way I did?
Yeah, like, is it because it's x, y squared?
Notice that, yeah, y is squared. So notice every point has a plus or minus on the y piece, because that's gonna come out the same either way. And then it's all dependent on, it's gonna come out to be the positive if they're both the same sign on the outside, x and z are the same side.
Okay.
They're gonna be positive. If they're different signs, it's gonna come out negative.
Okay, so you always go back, because also in the homework problem, like, I get multiple answers and I just never really know.
Then you plug them in, then it's just like finding absolute extrema. You plug them in and see which one's bigger than the other one. Yeah.
So I just-
When you only have one critical point, then you do have to do something else. Plug in something close to it so you can see if it's bigger or smaller. If you only have one critical point, can you tell if it's a max or a min? No.
It's just my concern was it just, what is the set for that, what is that range?
I got you. And how many of you guys have done 12-9? Was it, how'd it go?
I kinda got like frustrated, hit half of it, just like, screw this, I'm out of here.
Alright.
It's usually how math is.
Did you write that down?
Oh, no, I just left it blank.
Just draw a picture.
I'm gonna try forcing the paper.
Is there a specific one you want to look at, or?
35.
You were saying.
So let's go back to 12-8 and then do the Lagrange multipliers for one of the proverbs.
So solve 32 from 12-8.
Huh?
Oh, cool.
Yeah, but it's telling us to go back to 12.
It's not a bad idea because I will tell you this. Somebody asked me a really good question. Would I put a problem on there like a box problem or some materials problem or something? Yes. Whatever was in your homework could possibly show up on the test. Yes.
So this is possibly the
Yeah, exactly.
Thank you for the hand.
possibly it is going to be on the test.
It all depends on if I remember what I said. Just to be brutally honest. Which one we're looking at again? 30?
So it's 32 on 12-8.
Okay. The largest rectangular box, the first octant of the XYZ coordinate system that has one vertex at the origin. And the opposite vertex on the plane.
X plus 2y plus 2z equals 6.
Okay, cool. All right. Yeah.
We're covering 13.4 on the test too, right?
No.
Yeah, if you were here, you would.
Not 4?
We didn't really get up to 4 yet, so. All right. So this sounds a little bit like a problem where you would put a rectangle inside of an ellipse or something, and there's one vertex. And we had a problem like that before. This is obviously harder because now they're talking about the vertex is 0, 0, 0, and the opposite vertex is on some plane. Still the same kind of idea, just. So, if they want us to do this using Lagrange multipliers, what's my, can somebody tell me what obviously is the volume of this thing going to be? So here's my 0, 0, 0. Whatever my other vertex is, it's going to have to end up having an x piece, a y piece, and a z piece, right?
No one drops the other way.
Oh yeah, the first octant, that'd be good. Thanks, Jeff. It's just easier back there. Damn.
Yeah, sorry about that.
Screw it.
Just draw the box.
Here's the bottom of it.
Volume is 6, right?
There you go. You can get that.
That's good.
Oh, wow.
Take an art class. It would really help you.
Alright, screw it. There it is almost. Hey, that's a.
That's great. It's pretty useful.
Thank you. So one vertex is here. The opposite vertex is going to be up here. Did they say opposite vertex?
Yeah.
Good. Okay. Otherwise, this would be a little too free wheeling. But so the opposite vertex has got to be on that plane, right? Whatever that plane is sitting, it's got to be on that plane. So obviously, I've got this free range. Wherever this plane is, I can move that other vertex around on that plane, right? But those points have to lie on that plane. So this problem would have been really difficult back in 12.8. What they're trying to show you is, now that you use Lagrange multipliers, it's not going to be that bad, because this is my constraint function, right? Mm-hmm. What's my volume function going to be? Which is x, y, z. Because they gave me the vertex with 0, 0, 0, that's nice. So it's going to be x, y, z. So let's call that f. And this, of course, is g. So now just set up your stuff and go to town. which is easy to say, but let's see what happens here. So I want fx equals gx, right? Lambda, gx. So what's fx? yz.
Equals,
Gx is 1. Fy is xz, and what's gy? I mean, I'm sorry, times lambda. Sorry, the whole point of this is that multiplier, right? So gy is gx is 1 times lambda. What's gy? 2 lambda, 2, and then times lambda, and then finally xy. What's fz? I mean gz. 3 lambda. Okay. And then finally, we always have the given constraint function that we can use. So let me show you a little different way. Let me just show you some of the flexibility you have with this. What's 1 divided by 2? No, let me try this again. I like it. I gotta be more specific when I have smartasses in the room. What's equation 1 divided by equation 2?
y over x equals 1/2.
Y over x, and in the way you were ahead of yourself, equals 1/2. So that means y equals 1/2 x. Do you guys see what I'm saying?
Yeah.
I mean, you've done this before, especially when you have r cosine theta is x and r sine theta is y, and you're trying to, and then you divide them, the r's cancel, and you have a tangent theta. And, I mean, you've done this kind of thing before, where you have a system of equations, you can divide them by each other. And in this case, it's nice because z's and lambdas both go away. What do you get when you divide 2 by 3?
Z over Y.
Z over y equals 1/3.
Equals 2/3.
My bad.
So we're doing 1 over 3.
Yeah, you said 1 over 3. That's why I was saying.
Oh, did I say 1 over 3?
Yes.
So here's 1 over 3. What's 1 over 3? Oh, be quiet. What do you get?
Z over.
So it's 1/3. I like it. Cool. So you get z equals 1/3 x, y equals 1/2 x, and just for good measure, z equals 2/3 y. So do you notice how z and y are both in terms of x? So I can plug them into there and solve for x, right? For example.
That's one, right? Equal 2x.
Say again, sorry. Y over x equals 1 over 2, multiply the x up.
Y equal 2x, not
I'm sorry?
y equal 2x. It's the,
1/2, right?
yeah.
Yeah. So y equal to 1/2 x. Could you just multiply the x up? Or x equals to 2y, if you like that better. Right? So you have a lot of options here. You could say x equals to 2y and z equals 2/3 y, and then plug those in place of x and z and solve for y. You could do that if you want to, right? You could do that whatever order you want to, you could solve this thing. So we could plug in there x plus twice what's y, 1/2 x, plus 3 times what's z, 1/3 x. That's freaky. X plus x plus x equals 6. X equals 2, I like it. Which means z equals 2/3, which means y equals 1. Yes, ma'am.
So how would you do that in 12.8?
And where?
It's 2 hours. Number 32 in 12.8 is the same.
Oh, 12.8?
It takes 2 hours.
It's ridiculous.
Yeah, it took me 2 hours. With her
It is
help.
pretty gross. I'll tell you that.
Yeah. I know. Pretty insane.
So,
Did I need a help? I don't think
Yeah, you did.
Oh yeah, you did.
You did, Chet did. Like 4 people else.
so the whole thing with 12.8, and 12.8 number 32 is getting a little ahead of itself. It tried to give a couple problems like that where there was a constraint involved. So you can only use points from that place. So the example is like number, where's the one that I was using the other time we were doing this? Example 6
it's like this one.
was just like this, right? And I tried to show you the shortcut way to do it.
So on the test, are we gonna have to where we can't use the drum multipliers?
Yes, since 12.8 will be on there. But I won't give you one like this. I mean, let me tell you this. This problem was using a constraint function, and we've learned the right way to attack a problem with a constraint function now. So I'm not going to make you do this problem without letting you use what makes the most sense. I will give you a problem from 12.8, but not one with this extra constraint problem. Obviously, right? You guys with me?
Yeah.
So do you want to do this one or no? Okay. But it runs a lot like that problem we did together in example 6. In your notes, I gave you a quicker way to do it than what the book does.
Can we go over that?
Or a different way to do it.
Can we go over a problem in that way?
Yeah, can you do number 32 for 12.8 now?
What?
Well, that's what we were just talking about.
We can just go over a problem that Mike was.
Considering that I just told you I won't have a problem in the test like that one,
Yeah, I don't wanna waste time.
what would you rather do?
Not do it.
No, that's fine. We don't need it.
Do it.
So what else, what do you guys want to look at now? What have we left out?
I just want.
Can I go over the text?
What?
What do you guys think about number 6, by the way? I'm sorry, real quick. Number 6? Look at that real quick if you haven't looked at it yet.
You straight with you, I haven't done it yet.
You don't have to do it ever.
Yeah, I'm more worried about getting my homework done.
I would say yes. I don't know if there's a trick.
What?
I would say yes. That makes sense.
I think you guys would call it a trick, but it's not a trick. I mean, it's the central idea of what we're doing. The picture they're giving me, the R and the S, what is that? What are those points in there? What are those for?
For the individuals.
What do you do with those points?
Put them on your.
They're inputs. That's all they are inputs. Now, S, that box, is half as big as R. I agree with you on that point, but that's not the question. It's saying, is the integral of F over that region. So if I don't know what the hell F is doing over that region, if F is not symmetric with respect to the y-axis, then screw it. So imagine this, if F in this region, so here's one region, here's the other region, here's S, and this whole thing is R, right? So what if it was a plane coming through here, like this, right? Then over here, wouldn't it be negative? And over there, it would be positive? And if it was set up correctly, wouldn't it equal 0 then, the integral? Would it be equal twice the integral of this side? Hell no. Twice the integral of this side would be positive, and then double that. So it totally depends on what your function's doing. If your function's really high here, and then it comes down really low there, will I double this volume and equal the whole volume? No, this volume's big as hell, right? So if it's way up here for this, from here to here, it's way up here, and then it goes, whoa! When I get this volume, will double that equal to the whole volume? Hell no. So that is exactly the thing that I told you guys, and I know that no matter how much I say it, it's really difficult for it to be something you realize, but these pictures here are just my inputs. They have nothing to do with the actual function. So just because my inputs are symmetric. So it's just like me asking you this. All right, here's a function. There's a function somewhere. If I integrate from -1 to 1, is it the same as double from 0 to 1? And of course, you would probably go then, well, no. Because maybe it's this. Like that. Then is double this integral equal to the whole integral? Do you see how it applies here? I don't know what it's doing up here. I don't know if it's doing it here and then coming down, or it would have to be symmetric with respect to the y-axis. Then it would be, only in that case. And now you see why I put that on the answer key. Is that understood? It's exactly the same as this. Why does it not matter that 0 to 1 and 0 to -1 are symmetric to each other? It doesn't matter because those are my inputs. I need to know what the hell my outputs are. I need to know if my outputs are symmetric. And here, I don't know what the hell my function's doing. They don't tell me anything about it. Okay. Yeah, you would like that problem, Jeff. Hopefully number 4 wasn't a big deal. That kind of problem should be quick. Number 7, you try to integrate it the way it was, it would be impossible. Let me see. And then just a reminder again, 8 you can do with double integral. The number 8, if you look at the answer key, I use triple integrals just because, but the second step would be what it would look like with double integrals. Because what's my, so number 8, the region I'm talking about in number 8 is this region here, right? That's the region that I'm integrating over. Bounded by the cylinder, y equals x squared, and by the planes, y plus equals 4. So the cylinder, y equals x squared, would be this kind of thing here. For me, that's pretty good. So, okay. So that would be the cylinder there, right? So does everybody see why I'm not interested in that crap out there? I want what's contained in there. Okay. And I got the 4 because of the other things it tells me, but that's my region. If z equals 0, y equals 4. So notice y goes from 0 to 4. What's the function sitting over top of this region? What's the z equal? What's the function sitting on top of this region? What's it tell you? What's z go from to? Z goes from 0 to 4 minus y. So 4 minus y is what's sitting on top of this region. And I think I tried to draw it out for you. I know I got terrible skills today. I didn't even draw the whole plane, but you see that triangle that's at an angle there? The top of it? On the answer key? That's the part of the plane that I'm interested in. That's like the cap on top of that cylinder. So I like slice that cylinder whoop, at that plane, at that angle, right? So it's exactly like the problems in the double integral form they give. You have a z, a height, sitting over a region, right? So you could change your limits if you wanted to in the region that you're given, right? But to do this, you just have to double integrate the z, whatever order you want to. And you can see that my second step is exactly that. Double integral of 4 minus y. So you don't have to start with triple integration for that problem. Whew.
So I can think of it as a three integrals. Instead of z, I just solve for z. That's all it is.
Yeah, it's sort of akin to with double integrals when you don't really have to, you integrate the 1. So if I use triple integrals when I don't have to, I triple integrate 1. Easy idea. Same effect. It really wasn't necessary to do that, so I'm not sure why I did that.
I mean, on the test we can have something like this. How would I know if I'm not given the function? How would I know what function?
You have to give it.
Yeah, like here, because in problem 8, I'm not given
Oh, exactly. That's why like you solve for z, which to me it's easier to solve for z and think about z as a cap. It depends on the image you're left with. So this would be, this plane would come in and cut it off here, right? I did a terrible job there before. So you're left with just, it's horrible. Just this piece of it, right? On the inside. So you chopped it. So to me, it's easier, here's my region, my R. And then here's my z function sitting on top of that region. It's really difficult to define the region in some other plane. The xy plane is easy, because they give it to me directly, y equals x squared, right?
But I'm not integrating that.
No, that defines my region. That defines where my points are that I integrate over. So those apply to my limits. So I know what you mean. Now I know what you mean. When we do triple integrals then, what we're doing is we're allowed to use any of these points in this region, and on top of that, I can integrate some function. And now we're integrating over a volume. So now we're sort of doing, we're sort of pretending like we're in 4 dimensions. Because the reality is, when you go to something like physics or something, your variables don't have to represent spatial aspects, right? They could represent electrical conductivity at a point, and the heat at the point, and all this other stuff, all these other properties at the point. They don't have to be physical. But I'd still, the math wouldn't care. The math would just integrate, however many variables you got, integrate that many times. Yeah.
I wonder what the one is, like, how they take them off. You can just paint them.